Picture this. You're falling toward a black hole. Not being sucked in, not screaming through space like a rock in a slingshot. Just falling. Slow, almost gentle. And somewhere far behind you, a friend is watching through a telescope, waving goodbye. Here's the thing nobody tells you. From where your friend is sitting, you never actually fall in. You just slow down, and down, and down, until you freeze. A single frozen frame of a person, smeared across the edge of the dark, glowing dimmer and dimmer, redder and redder, hanging there for 1,000 years. 10,000 years. Forever. You, on the other hand, feel nothing. You cross the edge in a couple of seconds and keep going. 2 people. 1 event. 2 completely different amounts of time. Sit with that for a second, because it's about to get so much stranger. We've all been sold the same lie about black holes. The cosmic vacuum cleaner. The great space drain that roams the galaxy, inhaling stars, planets, light, anything dumb enough to drift too close. Hollywood loves it. A swirling mouth in the sky, sucking everything down its throat. And it's wrong. Almost completely wrong. A black hole doesn't suck. If you took our sun and magically crushed it into a black hole right now, keeping the exact same mass, do you know what would happen to Earth? Nothing. We'd freeze to death in the dark, sure, because there'd be no more sunlight. But we would not get pulled in. We'd keep orbiting on the exact same path we do today, calm as ever. Because gravity doesn't care whether something is a bright star or a black hole. It only cares about mass and distance. And the mass didn't change. So if a black hole isn't a vacuum, what is it? It's a hole in the shape of everything. Here's where you have to unlearn something you've believed your whole life. You think of gravity as a force. A rope. Something reaching out and grabbing you. Tugging you down. That's the Newton version. The version we teach kids. And it works well enough for throwing a baseball. But it's not what's really happening. Einstein figured out the truth over 100 years ago, and it still hasn't fully sunk into the culture. Gravity isn't a force pulling on you. Gravity is the shape of space and time itself. Everything in the universe, you, this planet, the moon, the light from your phone screen, everything moves through a single fabric. Physicists call it space-time. And massive objects bend it, stretch it, warp it, like a bowling ball dropped onto a trampoline. Roll a marble nearby and it curves toward the dip. Not because the bowling ball is grabbing it. Because the floor beneath the marble is no longer flat. That's gravity. You're not being pulled down toward Earth. You're rolling downhill on a slope you can't see. Now here's the part that should stop you cold. That fabric isn't just space. It's space and time, woven together. One thing. And when you bend one, you bend the other. Which means when you warp space hard enough, you warp time too. Slow down and really feel that, because it's the whole ballgame. Time is not some universal clock ticking the same everywhere, indifferent to what's around it. Time is physical. It bends. It stretches. It flows faster in some places and slower in others. And what decides the speed? Gravity. The stronger the gravity, the slower time runs. This isn't science fiction. It isn't a theory waiting for proof. We measure it. Every single day. The GPS satellites orbiting over your head sit farther from Earth's mass, in weaker gravity than you do down on the surface. And up there, time runs faster. Not by a lot. About a few millionths of a second per day. But if your phone's navigation didn't correct for that tiny difference, your maps would drift off by miles within hours. Every time you follow directions to a coffee shop, you are trusting Einstein's warp time to get you there. Your head, right now, is aging slightly faster than your feet. Because your feet are a little closer to the center of the Earth, sitting a little deeper in the gravity, so time down there runs a hair slower. Over a lifetime it adds up to a few billionths of a second. Meaningless to you. But the effect is real, and it's been measured with clocks in the same building, on different floors. So gravity bends time, everywhere, always. On Earth it's a whisper. A black hole takes that whisper and turns it into a scream. Because a black hole is what happens when you take a huge amount of mass and crush it into almost no space at all. Take a dying star, several times heavier than our sun, and squeeze all of it down into something you could walk across in an afternoon. The bend in space-time around that object isn't a gentle dip anymore. It's a bottomless pit, a cliff with no floor. And around every black hole there's a line, an invisible boundary drawn in empty space. Physicists call it the event horizon. It's not a surface. There's nothing to touch. It's just the point of no return, the exact distance at which the slope gets so steep that to climb back out, you would need to move faster than light. And nothing moves faster than light. Not you. Not a rocket. Not light itself. That's why black holes are black. It's not that they trap light like an animal in a cage. It's that beyond the horizon, every possible direction, up, down, left, right, leads deeper in. Out stops existing as a place you can go. For light sitting at the edge, forward is the only option, and forward means down. But the light thing? The blackness? That's just the trailer. The real horror is the time. Because as you approach the event horizon, gravity climbs toward infinity. And remember the rule, stronger gravity, slower time. So as you fall toward that edge, your time, from the outside, slows to a crawl, then a limp, then a stop. This is where those two clocks split apart forever. Let's go back to you, falling, and your friend watching from far away. For your friend, the outside observer, here's what they see. You approach the horizon, and you start slowing down. Not because you hit anything. Because your time is dragging relative to theirs. The light bouncing off your body takes longer and longer to climb out of the gravity well and reach their eyes. Your movements smear into slow motion. The light coming off you stretches out, its colors sliding from white toward red, then toward deep red, then toward wavelengths no eye can see. You dim. You redden. You freeze. And you never, from their point of view, actually cross the line. You just hover there at the edge, fading, a ghost pressed against the dark, taking an infinite amount of their time to complete a fall you finished ages ago. Because for you, it was nothing. From your seat, inside your own falling body, time feels completely normal. Your watch ticks like it always has. You don't slow down. You don't freeze. You sail toward that edge, and, in just a few seconds of your own time, you cross it. No barrier. No flash. You might not even notice the exact moment you pass the point of no return. You just keep falling, down toward whatever waits at the center. One event. Your crossing of the horizon. And it takes you 2 seconds and takes the universe outside forever. This is the real answer to the question. Why does a black hole stop time? Because time was never a fixed thing to stop. A black hole just bends gravity so violently that the difference between your clock and everyone else's stretches all the way to infinity. Two people watching the same moment, and they will never, ever agree on how long it took. Not by a little. By eternity. Sit with that. Standing at the edge of a black hole, one of your seconds could be 10,000 years out in the rest of the universe. You could fall for what feels like a single breath. And in that breath, empires you've never heard of could rise and crumble. Stars could be born and burn out. Your friend, your family, everyone you ever knew, gone, dust, forgotten, replaced 100 generations over, all in the space of one heartbeat, from inside. Now, I owe you the truth about the ending, because it depends entirely on which black hole you fell into. If it's a small one, a stellar black hole, the corpse of a single dead star, you're in trouble long before the center. The gravity difference between your head and your feet becomes so extreme that you get stretched, pulled. Your body drawn out into a long, thin thread of what used to be a person. Physicists gave this the most honest name in all of science. They call it spaghettification. You'd be torn into a strand of atoms before you ever reached the bottom. But if you fell into a monster, a supermassive black hole, the kind that sits at the heart of a galaxy, the horizon is so vast, and the curve so gradual that you'd cross it intact. Alive. Aware. You could sail past the point of no return without feeling a thing, already doomed, already erased from the outside universe, and not even know the exact instant it happened. And we have monsters like that. Real ones. Confirmed. At the center of our own galaxy, the Milky Way, There's a supermassive black hole called Sagittarius A-star. Its mass is about 4 million times the mass of our Sunday. 4 million suns, crushed into a single point, sitting quietly at the heart of everything we call home, warping time for the entire galaxy that spins around it. And back in 2019, humanity did something we'd dreamed about for a century. We took a picture of one. The Event Horizon Telescope, a network of dishes spread across the whole planet working as one, aimed at the galaxy called M87 and captured the first real image of a black hole ever seen by human eyes. That glowing orange ring, that cosmic donut that flooded the internet, that was real. That monster holds around 6.5 billion times the mass of our Sunday. We looked straight at the place where time goes to die, and we saw it glow. So here's where I want to leave you. We were taught that black holes are the universe's mouths. Hungry, greedy, roaming things that eat light and swallow worlds. And that story isn't just wrong. It's small. It misses the actual terror by aiming at the wrong thing entirely. A black hole doesn't chase you. It doesn't hunt. It doesn't want anything. It just sits there, silent, bending the fabric of reality so hard that the most fundamental thing you own, the forward flow of your own time, the one thing you thought was yours, the one thing you thought was the same for everyone everywhere, quietly comes apart in your hands. Light getting trapped was never the scary part. Light is just information. Light is just a messenger that couldn't get out. The scary part is that a black hole can take your single ordinary second and set it against 10,000 years of everyone else's, and it doesn't break a single law of physics to do it. It's just following the rules. The same rules bending time in your phone right now. Turned all the way up, you'll fall for a breath, and the universe will grow old waiting for you to land.